Hey everybody, this is Larry. This is me going Q4 of the weekly contest 377. Ooh, spoiler alert. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this Q4. Yeah, first of all, to be honest, I don't think this one is that much related to Q3. Certainly, I don't think I can use what I wrote for Q4 in Q3, or obviously Q3 and Q4. Otherwise, then this would be very easy. But yeah, I think there are a lot of reading for this one as well. You really have to. I mean, it's not really that hard to understand, but once you understand it, once you understood it, but it's just that the way they kind of, because I think they're trying to be very mathematically precise, but in being mathematically precise, yeah, but in being mathematically precise, they kind of fail to speak English, if you ask me. And I'm not saying that as in like, they should speak English, but just like they definitely went a lot, like the language is very mathy and specific, but not definitely like, there's no, the understanding part is a little bit trickier to come by for this one. Or just even like making it clear. But the short thing about these two rules or conditions is that basically, once you make a change to an interval or a substring, you have to either keep on making the same change, or you have to change something that is not related to it. So there are a couple of things you can do about this. A lot of different things, to be honest. And the tricky thing is picking the right amount or right selection of things so that it runs in good time. And the constraints are very, very hyper specific in a way, so you have to be careful. The first thing I noticed is that n is equal to 1,000. So I'm like, okay, we could play around some n square things. This came in a little bit later, and we'll talk about it in a little bit. There's only 100 items. Maybe that is good. I don't know. But yeah. So okay. So we recall from Q3, the idea is going to be the same, except for now, the idea is instead of doing one at a time, because you have this distinct property, if you will. I'm pulling up my drawing thing a little bit. But basically, the way that I think about it, this one is, to be honest, a little bit basic in how to, it's a very core algo, which is that, okay, so let's say you have some substring, and now you, it costs this much to update this. It costs this much to update this. You have basically you have all these things and all these costs, right? And of course, if you kind of draw out this visualization, with the caveat that you have to, or maybe another way to write about it is that you have an infinite cost if you don't match. So you have to match every character, but some characters or some substrings, you have kind of these things, and then now it just becomes a standard dynamic programming problem where you have the longest path in a DAG, right? Or yeah, longest path in a DAG is fine. Basically, you could think about, every time the two characters match, you have an edge, and of course you have all these edges that cost stuff, and basically you're trying to get from the beginning to the end in did I say longest or did I say shortest? Sorry, I meant shortest path in a DAG. Did I say longest path in a DAG? Huh. I don't know why I said that. But yeah, sorry. Shortest path is the shortest path in a DAG with all these edges in between, and you can kind of draw it out. Of course, that's easier said than done, but we'll go over the code in a second, just like now. Oh, I don't know what I clicked on. Probably the play button. But basically now you have a shortest path problem, and of course that's not necessarily the hard part. I think that's a pretty straightforward part, but in concept, right? Implementation is not as straightforward, but I just wanted to say, like that's the concept that you were built on. So okay, so let's start by going some code. I mean, the beginning is actually very similar to what we had for Q3. If you kind of go over that one a little bit first. First we put edge list. We convert everything to an edge list. You could probably do things a little bit more efficiently still, but maybe not. I don't know. But yeah, but basically we converted from adjacency list, from an edge list to an adjacency list, and then after that I just did classic Dijkstra or perhaps Dijkstra. This part is the thing that takes advantage of the fact that this is 100, so that means that this call is also only going to have 100 items. So that means that this is like 100 times log 100 or something like this. So then this is 100 square times. So let's call m is equal to the number of edges, and in this case, and in this case, then now this is going to be O of m times m log m, which is of course m squared log m. And of course, given that these are 100s, this is going to be pretty, looking pretty okay. By itself is pretty fine, but you still have to kind of do this part first. Basically, what this does is that now it gives me a mapping for every string to another string directly without having to recalculate, right? Which is always good. And then after that, it is kind of easy, but in concept, but very hard because of time limit exceeded, right? Because basically the way that I think the natural way that I want to write it, and this is in a way very basic kind of. And I actually have this commented out, but you can kind of look at the commented out code. Maybe I'll just keep commented out. But so we'll go with the commented out code first, and then we'll talk about one of my optimizations. So this is basically try to solve the problem for the substring, right, or for the suffix of the input. Like I said, this is the shortest path in the DAG. So you're basically saying, okay, what is the shortest path here? That is from the index going forward, right? And of course, if we have no more characters, we're done. Otherwise, basically set best equal to infinity. If the character if one character matches, then we just go to the next character, or at least we make it one of the choice. We don't have to. This is where it forks. This is where dynamic programming and things shine, right? So we'll go with this one real quick first. Basically, the idea here is pretty straightforward, right? An idea is that now it's saying, okay, let's jump one step ahead. Is there a way to change one character? Is there a way to change two characters? Is there a way to change three characters? ... right? And the can part is just whether the next, for example, next X characters, do we have an edge that map that to the target, right? And you can kind of look at the code and read it that way, right? Basically, we're saying, is there a distance that exists from the source to the target, and whether we have an edge for it. If we have an edge, then we just do a recursion based, leaping forward and adding the cost, and of course we'll minimize it over all these things. However, this is a little bit slow because index, of course, can go from 0 to n, and having an n loop is going to be too slow because, well, I mean, even though this would make it n square, this ends up being very expensive because basically you're constructing new strings in a lot of times, right? And as a result of all the sub-slice construction and maybe inefficiency and stuff like this, and maybe I could have made it a little bit faster, I don't know. But yeah, but still, it's going to end up being n cubed, right? Because this is the classic, like, you build one string, you build two string, and then ... This is actually n square here, and therefore this makes it n cubed. The way that I kind of get around it is by using this thing. And I actually tried I submit this afterwards, but at the time I didn't think it was going to go. But I did submit this afterwards, and it actually just times out. But the way that I kind of changed it around is that, okay, I noticed that m is only 100. So if m is equal to 100, then I just iterate on m instead. So that's basically the idea. The key part about this is that, and actually one thing that I could have done is actually cache this, because I actually don't know if this maybe we can kind of do this live a little bit. And then see if this is much faster. Make sure that it runs first. Yeah, okay. It would be funny if it times out now. Let's see how long that runs versus my old code. Yeah, so that actually shaves a second off, and so I should have done that actually. Now that I've kind of read the code a little bit, but yeah, but basically the idea here is that we're not doing any slicing. Sure, this actually is also O of n, so the complexity don't change that much. But there are two caveats, right? One is that there's early termination on this one, so it doesn't always go to n, though you could find cases obviously that contradicts that. But the second thing is that, to be honest, I take advantage of the fact that this function is highly optimized in Python. String operations are very optimized in Python because they're very basic and they're not on the usual Python time scale, if you will. But that's basically the idea about this one, and the rest of it kind of just follows through as well. And especially now that you're not keep on slicing, and apparently you shave for me a quarter of the time off. So maybe next time I need to do a little bit better about this. And even here, it's possible that like maybe we should take it to the extreme a little bit, because these slices do add up, and I kind of was like I kind of realized this at the time, but I just kind of but those are the expensive part, surprisingly, maybe, because the starts with is actually pretty fast. I mean, and even the slices are pretty fast. It's just that when you're doing it twice, it kind of why are you doing it twice kind of thing, because it is the most expensive part of this code. And you can see that we cut down another. I mean, maybe this is just fluctuation, so I don't know, but you can see that it actually I mean, maybe the magnitude there's some variance to fluctuation, but still, it definitely is obviously better. But yeah, that's pretty much it. Otherwise, this still is the same way to say the same thing here, which is, can we jump ahead X steps or something? Yeah. That's all I have for this one. Let me know what you think. Let me show you the top of the shortest path thing. This is me saying of the shortest path things. This is the in theory standard DP, but I don't know. I think that a lot of people have issues with the complexity, and I don't blame them. There are a lot of like TLEE things, because these two probably should maybe be the same, but in practice not as much. Anyway, that's all I have for this one. Let me know what you think, and you can watch me solve a live in contest now. Okay, I see. Do the same length. What am I doing on time anyway? Apparently people are really fast. The 6-pointer. about this join. I didn't read this through, so maybe I have to kind of read. This join makes it a different problem, maybe. Like a memorization problem and square, maybe. And cube is obviously too slow there. I mean, this is not that bad. Got used to all this. Okay, and now. Thousand. I need to try. I need to try, but it's a little awkward without it. This is so borderline fast enough in Python. Alright, just YOLO it. I'll do a try if I have to. Just real quick. Just want to double check. What happened here? Is the server having issues? Oh man. I was finally getting it too, but or is it my internet? I mean, this is okay, fine. Is my other websites working? No, so maybe it's just my internet. My internet's been kind of weird lately. Welcome back to New York, where somehow my really expensive Wi-Fi is not working. All right. Well, that's not right. But at least it's working. Well, if I want. How do I even get 3? How do you even get 3 there? B to C is 5. Okay, that's fine. Am I off by 1? I plus 1. No, that should be right. Why am I not doing the D and the E? Two is 3. 3 is infinity. So then why am I returning 3? 3 is infinity. But still, that's awkward. Alright, well, I mean, this is right. Is it fast enough? I don't know. Maybe that's good enough for me to test. Is that true? I guess so. A to B is 2 or something. But oh, because this is not true. So okay. So maybe I should just submit. But all right, let's just YOLO submit. It may time out. Now let's just test it, Larry. Maybe I should take advantage of that instead, to be honest. Maybe that's what I should do. Then it's just bound by 100. Okay, actually, yeah. That makes way more sense, maybe. Oh. Syntax check. Okay. Any typos? I mean, probably. Not too bad, but yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.